second video is now going to cover the next two examples. So examples 3 and 4, and it's in part because they do go hand in hand together. So just like we talked about in this first example up top, cosine of theta times the secant of theta minus cosine of theta. If you can FOIL out multiplication facts, just like we have in any Algebra 1 class, you also can notice that you could probably do the opposite and also factor trig identities as well. So if you take a look, cosine of theta is in the first term, and cosine of theta is also in the second term. So therefore, we are able to factor out a cosine of theta. When you factor out a cosine of theta from cosine of theta, you're just left with 1. And when we factor out a cosine of theta from negative cosine of theta minus sine squared, you are just left with 1 times sine squared, right? So if you factor out a cosine from both, you're just left with the number 1. And really, what's written in parentheses simplifies to something that would look like this. The cosine of theta times 1 minus sine squared of theta. Well, okay, sine squared of theta, 1 minus sine squared of theta especially, is a Pythagorean identity, right? That comes from the main one, sine squared of theta plus cosine squared of theta equals 1. If you subtract the sine squared of theta to both sides, you get that cosine squared of theta equals 1 minus sine squared. And that is that Pythagorean identity right there. So this turns into the cosine of theta times cosine squared of theta, which if you have 1 red M&M and 2 red M&Ms, then in total you'd have 3. So this really just turns into cosine cubed of theta. And voila. Okay. This one, pretty cut and dry, pretty straightforward. All right, example number 4. I want us to pay attention to this idea up here. So an algebra flashback, difference of two perfect squares, conjugates, right? X times x is x squared minus 2x plus 2x minus 4 simplifies to the difference of two perfect squares of just x squared minus 4. If you take a look, these two examples are complex conjugates of each other, and these two examples are complex conjugates of each other. So by what we mean with that is that this is going to create some sort of difference of two perfect squares examples, because it's the same idea, 1 and 1, cosine and cosine. However, you're using opposite signs. So this is the difference of two perfect trig identities, if you want to call it something like this. So let's work through one at a time. Okay, so this is 1 times 1 is 1. 1 times negative cosine is negative cosine of theta. Cosine of theta times 1 is positive cosine of theta. I'm sorry, and they're not squared. I'm just adding that in right now, and I'm not supposed to be. So they're just cosine. And then cosine of theta times negative cosine of theta is negative cosine squared of theta. So if you take a look, if we're just handling one at a time, negative cosine and positive cosine, those cancel out. And we're left with it when we can put it in one parenthesis, 1 minus cosine squared of theta. Okay, beautiful. Now let's do the same thing with the other two functions, right? So cosecant of theta times cosecant of theta is cosecant squared of theta plus cosecant of theta. So cosecant times 1 is just cosecant minus cosecant minus the number 1. So then if we go ahead and cancel out like terms, we see that cosecant and negative cosecant cancel out. And in parentheses, we're left with the cosecant squared of theta minus 1. Okay, so both of these, if we take a look at our 3 Pythagorean identities, both of these are Pythagorean identities, right? For instance, 1 minus cosine squared is just sine squared. Times cosecant squared minus 1. comes from this Pythagorean identity. If we subtract 1 to both sides, we're left with cotangent. So this would be cotangent squared of theta. So now, sine squared of theta, there's not too much we really do with it. Kind of just going to leave it the same. But cotangent squared is just the relationship of cosine squared over sine squared. So we can rewrite this out as the sine squared of theta times the cosine squared of theta all over the sine squared of theta. And if we take a look, sine squared and sine squared cancel each other out. And we are simply just left with the cosine squared of theta. And there you have it. Okay, so this was video number 2. This covered example problems 3 and 4. And now hopefully you guys will be able to load the last page of your notes, these 2 example problems. It will be on one video as well. And then you guys will be able to start your homework, which was your homework from yesterday, the day 7, that you're just going to keep continuing on with. All right, next video. Ready, go.